You just like flip it from backwards.
I think I need the camera quality for. We got it. Right.
Well, my name is Fred Simonian. I'm just got that. You asked me to come here and give you some presentation about electrical engineering. Well, I'm an electrical engineer, PMP stands for Project Management Professional. Later on you can see having an electrical degree can go to so many other fields, not just electrical. So let's start. How many of you want to be electrical engineer? 3 of you. The other one is not sure. He's not sure. 3.5. Well, what you guys do right now in the engineering club is robotics is like electrical, mechanical, and programming. Right? So I got more of you who go to electrical engineering, but I guess no, some of you want to go to mechanical engineering. Hey, doesn't matter. Yeah, biomedical. Okay, I'll go over my experience, all right? What I did, and what was my career path, and where I ended up. So I'll talk about my education. I'll kind of go over, maybe some of you already know what's the difference between electrical and electronics engineering. I'll talk about what's electrical engineering subdivisions. Electrical engineering is not one subject, it has several subjects. I'll talk about my first job, which was the best job I ever had. It was with Bechtel. I don't know if you're familiar with Bechtel Power Corporation. They're the, you know?
Yeah, my grandpa was a long time nuclear employee there.
Yeah, I was on nuclear power plant. That's where I started.
At Hanford?
No, I was on Palo Verde, Arizona. It's you want to know electrical, you go nuclear. That's where you really learn everything about electrical engineering. So we'll go over that, and I talk about electrical engineering deliverables. When you go into an office, a company start working, what you would do as an electrical engineer. Not what you did in the college, what you do actually in real life, which I never learned in college. Yeah.
What school did you go to?
USC. So, yeah, I got my bachelor's degree in electrical engineering from USC. We'll go over when I go to education, I'll tell you guys. Second job was with Parsons Corporation, which is the headquarters was in Pasadena. They're also contractors. And they do projects, oil and gas projects, infrastructure projects, and Department of Energy. All Department of Energy projects, variety of projects related to nuclear and explosives. Talk about that. Then third job was with Saudi Aramco. I went to Saudi Arabia for 20 years on oil and gas projects. As you know, Saudi Arabia is one of the biggest, not one of the biggest oil producing countries. So I was involved with there. And I'll give you a few recommendations what to do, which nobody gave me that recommendation based on my experience. You take it good or you forget about it. Now, I got my electrical engineering degree from USC, Bachelor's of Science. Yes, it's Bachelor of Science, I think. And I got a graduate study in construction management. It's a master's degree that USC offers. I didn't finish it because I went halfway, but because of traveling a lot. As an electrical engineer, depends what you coach, what company you work, they send you a lot to the field in the construction. So I was involved in that period. I was involved in construction take the fundamental of engineering. After you graduate, when you're working, then you take your fundamental of engineering. It's not an easy test. I had to take twice to pass. Especially when you're away from school or college for 2-3 years, it becomes more difficult because you forget and you have to go and review and remember all this stuff. They have it like 2-3 times a year. In my time, it was called engineering training, the IT. But now they changed it, they call it fundamental of engineering. You have to have this in order to get your professional engineering. Professional engineering is good because the companies you work, they value professional engineering because you can sign the drawings that you develop. Only the professional engineer can sign the drawings, the certified drawings for construction. So that's why it's good to have a professional engineer. It's not just in electrical, mechanical engineer, civil, structural. They all have, they can apply for professional engineering. Okay? And then later on, I took the project management professional certificate, PMP. If you go into management, then you need, this is a good one to have. So think about this stuff. Nobody told me. I learned this while I was working and I was learning and hearing from people. And this is what I did. But unfortunately, I didn't take the PE because again, I was traveling too much. I couldn't concentrate. It's not an easy test. You have to concentrate and spend a lot of time. So if you guys are not traveling too much and you're working for an engineering company, make sure you take your fundamental of engineering as early as you can, and professional engineering. Professional engineering, you have to have minimum 4 years of experience, working experience, before they allow you to take that license or that test. Okay? So this is the education, my education, and yeah, electrical engineering at USC. Now, what do you need to take in order to graduate from USC with electrical? Since I went to USC, I'm familiar with USC. So USC requires you to take 128 units. 128 units to graduate. You can see that writing, English writing, 7 units. That's probably 2 courses. One is 3 units, one 4 units. Unit is, every unit is like 1 hour a week. So if you have a course which is 3 units, that means it's 3 hours a week. You have a lecture. Or 4 units is 4 hours a week lecture. Okay? So general education is 24 units. Math requirements 12 units. Usually math is 3 units or 4 units. Physics requirements is 12 units. That's about 3 physics you have to take. Engineering, this is a general engineering. But the key one is here. Electrical engineering, 4 units. Usually they're all 3 units. Each electrical engineering course is 3 units. And these units, 40 units, it covers communication, electronics, electrical, circuits. So while you go through this process, you learn by taking these courses, you get an idea of what you like. You want to go into electrical, electronics, communication, circuits, signals, all right? So this is where you really start understanding what you like. Right now, you don't know what's going on, right? But taking all these courses, I found out I like electrical. And I'll tell you what's the difference between electrical and electronics. But USC calls it electrical, general. Because first 4 years is general and it goes under the name of electrical. But in reality, electrical is power engineering. It's an old-fashioned name, power engineering. You work with high voltage systems. Electronics is low voltage, which is circuits. I'll show you in the next presentation. And then you have engineering electives, 16 units. All these electrical engineering electives are electrical courses. It's not mechanical or biomedical. It's all electrical. These are all electrical courses. And if you're really interested to know what are these courses, the list is in the if you Google it, you'll find it. tells you in detail what are these courses. And free elective, you can take, I'll recommend you to take economics for engineers. This is a very good course for engineers to learn about economics. And PE is part of this. PE or anything else you can take mechanical, biomedical, aerospace. That falls under these free electives. But you cannot take more than one unit in physical education. And the total is not 128. When you have 128, then you can graduate with electrical engineering BS degree, bachelor's degree. Okay? So this is just to know what you need in. Well, this is exactly what USC needs, but other colleges are pretty much with this. It's aligned with this. Maybe different units, maybe they have 130 units, 134 units, but it's pretty much same. Okay. Now, what's the difference between, anybody knows the difference between electrical and electronics engineering? No way. Well, you can read it. Electrical engineering is power engineering. You work like utilities, nuclear power plant, solar plant, wind, hydro. They're all done by electrical engineers. These are all high voltage transmission lines. All this power that comes from nuclear power plants or any power plants to the houses, you have seen those transmission lines. Those are all electrical engineers, not electronics, electrical. Power grid, substation, power distribution, how to distribute the power in the city, how to distribute the power in a refinery or in the school. These are all by electrical engineers. Control system or industrial system. Controls, I'll show you some example of what control system is. That's also done by electrical. So transmission line is a separate field by itself. Alright? So if that's something you go into the master's degree and you specialize in this transmission line. It's a different ballgame. Now electronics, it's the microchips, processors, alright, and semiconductors, communication devices, the mobiles, Wi-Fi, Bluetooth, phones, TV. These are all electronics. Easy way to remember, electrical engineering is a big power, high voltage power, and electronics is a small power. Circuits, like you were talking about, circuits are all electronics. But at USC, under the bachelor's degree, all fall under the electrical. Alright, but you do take all these courses, like electronics, microchips, processors. You do all these courses, part of that 40 units electrical. You do take all this and you figure out what you like. I liked electrical, I liked power. I didn't like electronics. Even though I took a lot of courses, but that's how you know what you're good at, or what you like, what is easy to understand and digest. If you have questions, you have to stop. What are the electrical units of the region? Again, all these you take it in the bachelor's. So to go into the master's, then you start thinking, well, I want to go into power engineering, electronics, telecommunication. These are all could be a master's degree, specializing in what you want to do. Alright? It's pretty much self-explanatory what is computer engineering is, control system is, telecommunication. These are what electrical engineering subsystems are. And usually you go into this in the master.
Question. For most jobs out there, are they specifically about like these subdivisions, or are there a lot of jobs where they're kind of interdisciplinary for some of these?
No. For find a job, you go to a company. Okay, for example, you go to Apple. Apple doesn't need an electrical engineer. You got to look at the people who know how to you have to know those stuff.
So you need to know both of them?
I mean, no, either one. But for example, Apple is what is computer, right? Computer and iPhone. Computer, you have electrical, right? Programmer and computer engineering, signal processing, and those are the ones they really need. So, for example, I apply Bechtel. Bechtel only needs power. Or it doesn't need anybody's communication. Alright. So you need to know what company you're applying and what the specialty of that company is. You know, you just can't just go with electrical apply Apple. So I don't need you.
So would you say it's a like bonus to have specialize in multiple of these, or would you say it's better just to focus on one?
You have to, in masters, you have to focus on one thing. But in bachelor's, it's general.
Okay.
When I graduated, I knew very little bit of everything. That's it. And but I like electrical, I like power, so I went to applied power company. Bechtel was a power company, doing nuclear power plant. Right?
Yeah.
So, you have to decide what you want to do, what company you want to work with, what you like actually, and that's what you company, you gotta see what you like out of these 6 sub-disciplines, which one you like most. And probably you don't know it now, but once you go into bachelor's degree, once you take those courses, you realize what you like.
So you took your master's while working at Bechtel?
The bachelor, no.
Oh, okay, sorry, you took your master's.
No, master's was construction management.
And you took that before?
I didn't go to master's for electrical. There was no need.
I see.
If there was a need, I would have, but I saw, you know, depends on person. You know, when you start working, you know, okay, I wanna work like 10 years electrical, but then I wanna become a project engineer. Project engineer does everything. You know, he works with every discipline. Now, you know you can be a project engineer when you work as an electrical. When you work with electrical, you interface with mechanical, you interface with instrumentation, you interface with civil structural, and then you see how you understand their work, because you have to work with them. The project is not just only electrical team. There's mechanical team, right? When you're building a refinery or nuclear power plant has a nuclear engineer, mechanical, instrumentation, electrical, civil, structural. They have everybody in there. And you have to work with them. You cannot just design electrical without knowing how the control works. You understand what I'm saying?
Yeah.
Control, like, and you have to work even with fire protection and security. For example, when there is a fire in an area, electrical should know, okay, if there's a fire, I gotta get that signal and bring it into the control system and shut down these pumps. Or I gotta take that signal and start a pump. That's all done by electrical guys. Okay? But you have to interface with all this discipline. Once you're good and you like interacting with different disciplines, you go into project engineering. You come out of electrical, and project engineer is a group by itself. They're all engineers. They're all experienced engineers with mechanical, electrical, civil, structural, and you control the scope of the work. You control the project, and you report to project manager. All right, but you don't do electrical. You don't do electrical engineering anymore, and that's what happened to me. I did like 10 years engineering. They would do the electrical engineering, but they pulled me out and they put me in project engineering.
Oh, so they decided that.
And you have to show the interest.
Oh, I see. Okay.
All right, and they have to see that you are good in interacting with different disciplines. Some people are not. They just like to do their work, you know?
Yeah.
And they don't like to interact. Somebody has to tell them, push them, okay, do this, do that. But they don't go out there and interact, get the information, right?
Yeah.
So there's a lot of those people.
Okay. Thank you.
Okay. Like I said, my first job with Bechtel, they were the They are masters of nuclear power plants still. And I love this job. The only reason I left Bechtel because nuclear power plant went down. Everybody was scared. Everybody thought it's not safe. It's a safety issue, and also there were projects got canceled or it was finished and nobody was coming up with new projects for nuclear power plant. So since I like nuclear, I'm going to talk more about nuclear power plants. I worked, and that's where I really learned electrical engineering. That's where you see everything about electrical engineering. And none of them was I learned in USC. None of them. And unfortunately, USC doesn't take students to this kind of companies to show what electrical engineering is. They don't. Another thing about USC is their lab. They have very few lab activities. Mainly is going to class and reading books, taking tests. That was one problem. Like MIT, for example, a lot of lab work. You learn better and faster when you see actually how things work. At USC, it's all theoretical. You have to read books and go to the class and lectures. Very few lab works. Anyways, I worked on Palo Verde nuclear power plant generating. It's in Arizona. If you go Phoenix, 50 miles before you reach Phoenix, you'll see they call it Palo Verde generating station. They don't call it nuclear. They call it generating station. In reality, it's a nuclear power plant. Yeah.
So would you say like going into some trade would be a good pathway? Is that
Going what?
like skilled trades, like having experience in that? Would you say that would be
Yeah, sure. Like, give me more example. Like what?
like
what
a
trade you're talking
lineman?
about?
Like
Lineman?
having experience.
You don't need to have a degree for lineman.
But it's would having, because you said that a lot of the colleges only teach theoretical, so actually being in these places that use these facilities.
Yeah, you can go, yeah. They make better, maybe more money than engineers. But you have to go up top of the transmission lines and it's a dangerous, little dangerous. Why, you wanna get into the trade?
I don't know. I've had some experience with that, so I was just wondering.
Yeah, sure. Yeah, I'm just talking about electrical engineering, but you can do anything you want. I'll take it.
Okay, yeah.
I didn't do those kind of stuff. I wasn't interested, but if you're interested, why not?
Yeah, I probably wouldn't want to be up there, but I just want to see if it probably it helps.
Sure.
In the area.
Definitely. You know, well, you make a good money too.
Yeah.
So you have to keep travel and 24 hours a day on business call and
Yeah.
something happen at night, you have to go and fix it.
And not as fishy.
Yeah. So, anyway, yeah. What was it? Yeah. It's the largest nuclear power plant in the United States. It's like most nuclear power plants, this nuclear power plant is located in the middle of the desert. There's no water. Usually all nuclear power plants are next to a river or ocean or a sea, because that's where they get the cooling water. But this nuclear power plant is right in the middle of the desert. Yeah.
So then how does it like keep cool essentially?
Yeah, well, this is where I say. Wastewater. They're creating a lot of wastewater for this plant because there's no water. So they get the wastewater and bring it to the plant, pipelines. So I worked 3 years in the office on the design, and I went 2.5 years at the construction site. And I mainly work on Unit 1. I'll show you later. Reactor capacity is 30 gigabyte. You guys know gigabyte? Mega? Not gigabyte. Gigawatt. Gigawatt. You guys know what it is?
Yeah.
How many kilowatt is gigawatt?
You know,
or 3.8. Each unit is 1.3 giga. Or 3,810 megawatts of power. So this nuclear power plant can power about 4 to 5 million houses. And this power plant is a combination of Arizona Public Service, Southern California Edison, and this power is coming from there. So the 3-4 utilities companies got together for this power plant because it's very expensive. The cost was about $12 billion. So you need to have several utilities get together to start. Obviously, the carbon-free energy, as you guys follow the news, nuclear power plants become very popular these days, right? Our president is a pro-nuclear power plant. So this means in future, to be carbon-free energy, they have no choice to go to nuclear. Solar and wind, they're not reliable. And they cannot power continuously factories or houses, and there's no wind, there's no, I don't know, there's no sun, I mean, it's not reliable. The only reliable power source that is carbon-free is nuclear. That's it. No buts and ifs. So I think nuclear is coming back. I think, I don't know if you guys heard, Microsoft paid, I don't know, few $billion to one of the utility companies to start the commission 3 Mile Island nuclear power plant. So, as you can see, nuclear power plants are coming back. Nuclear power plants are designed for 40 years, but they can extend it for 10 more years or by renovating it, replacing the equipment and all that. This is the Palo Verde nuclear power plant. I don't know if you can see, those are all the things you see coming out of the cooling tower.
So you said nuclear power plants were designed for like 4 years, right?
40 years.
40 years. Okay,
40
so like what's the main way that they break down? Like what's the internal issue that prevents them from lasting longer?
Because of the material equipment you use, the manufacturers say this is good for 20 years, 30 years, 40 years.
Okay.
All right, so
And it
it's
just
based on
degrades over time and it's gonna...
Yeah, the reactor vessel itself.
Oh, okay.
You know, these are not built to last forever. They all have a life cycle. The life cycle of the material used in the nuclear power plant is 40 years.
Oh.
This is the Palo Verde nuclear power generating station. These are the steam you see going out, this cooling system. Those are the dome that you see there. That's where the reactor is, the steam generating system and the motors. There are 12,000 horsepower motors. Well, this is how the nuclear power plant works. You can see that that dome is this one here. Oh, I'm not sure. You can see the dome, right? That's where the dome is. This is the reactor vessel. This is the steam generating vessel that I'll show you later. These are the pumps that bring the water from here. Cold water goes into the vessel, gets very hot, turns into steam. Steam comes there and goes into the turbine and generates power. And the steam goes down to this condenser, turns into the cold water. That's why it goes into the cooling, actually goes into the cooling tower, comes, temperature drops, goes back, and it just continues, right? The power comes out here. Steam turbine generator creates the power and goes out to the transmission line. Is that clear? Yeah. So this is a nuclear power plant. This is inside the dome. This is the reactor is in the middle. That white big vessel you see, that's the steam generating vessel, and that green or yellow, this thing is motor. About 12 to 15,000 horsepower motor. These are huge motors, very expensive. This is a turbine generating building, the biggest building. This is where the steam comes there, turns the generator, and this is where the power comes out. And those pipe that goes in and out, that's where the steam, hot steam comes in and goes out to the tower to get cool. This is a control room, a huge control room. There's maybe 20, 30 people are working in there. Everybody has his own responsibility, and it takes them 2-3 years to train them. While we were constructing this, those 2 years, all those operators were working there, trying to learn how the system works. So it's a good field to be in, to be a nuclear power operator. Well, in reality, when you work as an electrical engineer, these are the drawings you develop, calculations you do. This is the real thing. Something that I never learned at USC, they never told me, they never took me to any company to show me what electrical engineering is. Well, it's a single line, you have to develop single line diagrams, or one line diagrams. It looks like something like this. This is a single line diagram. This is typical for any facility, refinery, gas plant, nuclear power plant, any industry. This is pretty much the same type of drawing to develop, but of course, it depends what kind of motors you have, how many motors you have, what size motors you have, so it all depends. It all changes the value of transformer. The top line, 115 kV, is the power that comes from utility. You bring it into the facility, and that's the transformer. We dropped, but I don't have it. I didn't realize it like this. Anyways, this is a single line. I don't have to go into details. Just to know what single line looks like. You have to do all these calculations. ETAP is a very well-known electrical software they use for short circuit, voltage drop, motor starting calculations. It goes in, they do cable sizing and so many stuff, but it usually is used for those VIS. And you learn this in the company, they teach you. That's where you learn, not at the college. Cable sizing, again, you learn in the company. All these things you see here, you learn in the company. They teach you. You work with an experienced electrical engineer, and they give you a go-bys, and they sit down next to you and explain you how to do it. So, schematic diagram, that's another big important deliverable that you have to develop. This looks like a very, very basic, simple schematic diagram, how to start and stop the pump. Alright. Yeah. Grounding diagrams, you have grounding diagrams, you have a data sheet and specs. You have to develop data sheet, what kind of transformer, what size, what MVA, or motors, what kind of motors, UPS, uninterruptible power supply, or you have to do equipment layout, how many equipment you have, what size they are, so you can size the buildings, switchgear building, where does equipment go? You have to size all those, and you give it to architectural, and then they design the building. But you have to tell them what size it is, and where the equipment are located. You have to write the scope of work for electrical to the construction contractor. You have to coordinate electrical activities, engineering discipline, like I explained before. You have to prepare monthly progress report. The attending weekly meetings, telling what you did, what are the issues, what are the problems. You have to explain the meeting to the project engineer, project manager, and to other disciplines. So if there's anything that is a major issue, the whole group gets together and solves it together. And you do the material takeoff. For electrical, how long cable, what type of cable, all of that you have to do yourself. Okay? So I've done all this, and it's fun. It makes it exciting. It's not boring. You have so many things you have to do, and with different people to interact. Alright? This is a typical substation building. You decide what size this building should be. I'll show you inside of this building. Those stuff that goes up and goes in, anybody knows what they are cable trays. That's how cables go in. They go from underground, they go up into the cable trays and into the building. So you size the cable trays. And those little boxes you see next to them, those are transformers, control transformers. For lighting, alright, for control system. Small 120 volt. There are 480, 120 volt transformers. These are the transformers. These are power transformers that brings the power into the substation building. Usually 115 kV power comes in, goes into the transformer, and goes down to 13.8 kV. Usually these facilities work with 13.8 kV and below. But what it comes in from utility is higher than 13, so you have to bring it down. So it's a transformer. Now, everybody knows why we have walls between transformers? These transformers usually explode. If there is a malfunction or something, it catches fire or explodes. So they put it so it doesn't damage the next transformer. So it's a standard. You have to put this wall between transformers, power transformers. This is the switch here. This is the 13.8 kV switch here. That transformer that I show you. The low end comes into this switch here. And you guys don't know what switch gear is, right? Switch gear is where control, okay. This is what switch gear is. Switch gear protects expensive equipment like motors. Motors are all expensive equipment. Extremely expensive. Like 12,000, 15,000, 5,000, 4,000 horsepower motors that are not cheap. So you protect them by putting relays, protection under voltage, short circuit, ground fault. Put all those relays in those switch gears, in that switch gear. Okay? And each compartment takes care of one motor. So you saw there are several compartments. So each compartment takes care of each motor or each load. So they are separate. So that's how you distribute the power. Okay, so that's switch gear, and this is that switch gear I just showed you, and the power switch gear 13.8 kV goes back to the transformer. Voltage brings the voltage down to 480 and comes back to the motor control center. This is the motor control center, the little one. Okay? All the cables are overhead cables in a cable tray. So you design all these cable trays at the top. Usually good at the bottom, but the best is to put it in the top. We always put it at the top, but there's an option of doing it at the bottom. So this is a typical installation inside a substation. This is a UPS. You have to know which loads are required power. If power goes out, if there's an emergency, you don't have power, which devices should be operating in order to bring down the facility safely, shut it down. So all those equipment or switches or transmitters, they all go on the UPS system. So you size the UPS, there's a calculation for UPS. So this is what a UPS looks like. Uninterruptible power supply, UPS. Alright? You can see all the cables going in from the Okay, second job, like I said, the nuclear power plant was almost, nobody was interested, it was too expensive. We're afraid of nuclear incidents, so they canceled all the projects. So I moved from Bechtel, I went to Parsons Corporation, with headquarters was in Pasadena. So there, this company wasn't doing any nuclear power plant, but they were doing nuclear facilities for DOE, Department of Energy. They were processing the nuclear from their, I don't know, their, well, I use that word. Okay, anyway, I got involved with the DOE project and CapEx plant, which was explosive, where they processed explosive material. And that's where I got into oil and gas projects. And this company was doing international projects, and they were doing a lot of projects for Aramco, Saudi Arabia. So that's where I got to know this company, they got to know me. So I left this company, I joined Saudi Arabia. I stayed there for 25 years, working on oil and gas projects, mainly on refinery, gas, and bulk plants. I won't go into the details of refining a bulk plant, we'll just skip since we're running out of time. My recommendation is, during your senior year in college, make sure you go to those career center activities, which I did. And first job that I got, I didn't go through interviews. They hired me directly without interviews. Why? Because I went to one of this career center, the companies come and they introduce themselves. So Bechtel owner came to USC. And he talked about his company, what the company does. So I went and got his business card, the owner's business card. So after I graduated, I went to the Bechtel and personnel. I filled an application, and there's a place who referred you, and I gave them the owner's business card, and that was it. And I was hired after 2 weeks without any interview. I was hired. So I recommend you to go to those orientation. The companies that are coming, make sure you go there, talk to them, see who they are, get their business card, and it may help you guys like it did help me. Like I said, take your fundamental engineering exam prior to taking PE as soon as you can after you graduate. Right? It's easy because you're still fresh, you still remember all the subjects. It should be easier. If you wait 2 years, it'll be more difficult, like happened to me. And then after you take that fundamental engineering with 4 years of experience, you can apply for professional engineering license. All right. I also recommend you become a project manager, to become a member of Project Managers Institute, PMI. PMP is offered by these guys, so it's very general information. They always have seminars, meetings, articles about project management. Because when you work in a project, there's always a management, there's always a project engineer, regardless of the electrical, electronics, IT, whatever it is. So this is highly recommended. So anyways, I read this report. Okay, that's it. Thank you very much.
So currently, nuclear power plants, they use nuclear fission, right?
Nuclear what?
Nuclear fission.
Yeah.
To like, so how close do you think like we are to like finding a way to like harness like nuclear fusion?
Oh, that's not that close.
Not that close.
They're still working on it. By the way, it takes the nuclear power plant. It takes every 24 months they change the fuel. And the shutdown is about 40 days, and during this shutdown, they do other maintenance work or replacement or upgrade they have to do. So every 24 months, they replace the fuel. That's how long it takes. Anything else? Okay.
Thank you. If anyone needs SNHS lecture credits, come up to me and I'll write your name down.
All right, thank you very much for coming.
Theoretical.